Hello everyone, let's work on the function log with base 2 of x plus 8 minus 1. We want to analyze the function and finally graph it. The first thing that we need to do is find the domain and the range of the function. To find the domain of a logarithmic function, as every other function, what we need to do is to look at regions that they will limit the domain, that will limit the number of values for the x. Now we know that the log for every a exists only if the a is greater than 0. So this means that the x plus 8, that is the argument inside the logarithm right here, should be greater than 0. So we need to solve the inequality that will give us x greater than negative 8. And of course we need to rewrite this in an interval notation from negative 8 to positive infinity. The next step is to find the range for the logarithmic function. The range for any logarithmic function is the same, from negative infinity to positive infinity. This is true for all logarithmic functions independently of the base of the logarithm. The next step is to find the asymptotes. Let's look at the asymptotes. The logarithmic functions have only vertical asymptotes. We need to remember that, and of course this is expected because the exponential functions have only horizontal asymptotes. Remember that the general the general curve for the logarithmic function, for any logarithmic function, is this. So it increases slowly to the positive infinity, and it decreases asymptotically to one vertical asymptote. The vertical asymptote for the logarithmic function in general depends again on the argument of the logarithm. So what we need to do is take x plus 8, that is the argument of the logarithm, and solve it for 0. This will give us that x is equal to negative 8. The vertical asymptote for this logarithm is equal to x equals to negative 8. The next step would be to find the x-intercept and the y-intercept for the logarithm. Let's try to find first of all the x-intercept, the y-intercept. The y-intercept for the logarithm will be when the x value is equal to 0. So, in order to find that, what we need to do is consider the f of 0. The f of 0 is going to be the log with base 2 of 0 plus 8 minus 1. And this is equal to the log with base 2 of 8 minus 1. But remember that we can rewrite the 8 as a power of 2. 8 is nothing else than 2 to the third. And then we can apply the properties of logarithms to rewrite the log of 2 to the third as 3 times log with base 2 of 2. But I hope that we all remember that the log with base 2 of 2 as the log of a number with the same base for any number is equal to 1. So basically what we have right now is nothing else than 3 times 1 minus 1. And this is equal to 2. So this will give us the y-intercept, that is the point 0, 2. Let's move on now and try to find the x-intercept for this logarithm. How do we find the x-intercept for this logarithm? The f of x must be equal to 0. So what we need to do is to set the equation log with base 2 of x plus 8 equals to 0. And we need to solve this logarithmic equation. In order to do that, we have to rewrite the 0 as a log with base 2. And of course, this is going to be equal to nothing else than log with base 2 of 2 to the 0. So this now is equal to the log with base 2 of x plus 8. Since we have now logarithms, and we have one logarithm on the left side and one logarithm on the right side, and the logarithm of the left side is equal to the logarithm of the right side, this simply means that the arguments of those are equal. So x plus 8 is equal to 2 to the 0. But 2 to the 0 is equal to 1. So I have the simple linear equation x plus 8 is equal to 1. And I solve for x, and this gives me x is equal to negative 7. So this means that the x-intercept now is negative 7, 0. And now I am ready to continue and graph my function. I have the domain, that the domain in this case is equal to negative 8 to plus infinity. I have the range. I have the vertical asymptote. And I also have the y-intercept and the x-intercept. 2 points for the logarithm. One more thing that you want to do before you graph the function is actually to go back and look at your function. See if there are any transformations that they are rotations around the x or the y-axis. As we can see, the sign in front of the logarithm and the sign in front of the x, both of them are pluses. So this means that there is no rotation here. There is no rotation around the x-axis, then there is no rotation around the y-axis. If one of those signs was negative, then I would have a rotation. Since I don't have a rotation, then this means that my function will have the regular format, so the curve will look like this. Knowing what is the form of the function before starting graphing the function is always very helpful. So let's go ahead now and try to graph our function. The first thing that I want to know is what is my vertical asymptote. I want to remind you that the vertical asymptote is x equals to negative 8. So I go down here and I'm going to graph the vertical asymptote. Negative 1, negative 2, negative 3, 4, 5, 6, 7, and 8. So my vertical asymptote will be this vertical line right here. And my logarithm will be asymptotic to this line. The next step that I want to know is what is my x-intercept. And I remind you that the x-intercept is the point negative 7, 0. And I also want to know what is the y-intercept. And as you can see, the y-intercept is 0, 2. So those 2 points will be points of my logarithmic function. So the next step that I want to do is actually go ahead and graph the function. I already know what is the shape of my function, and I graph it appropriately in order to show that it's asymptotic to the x equals to -8. And that's our graph. One more thing that we want to do is to find the inverse of this function. So let's do this together. How do we find the inverse of a function? We start with the original function f of x equals to log with base 2 of x plus 8 minus 1. At the next step, what we do is that we interchange the f of x and the x. So now I rewrite this as y, and I make the y x and the x y. And now what I want to do is to solve this equation for y. Now remember that this is nothing else than a logarithmic equation. And in order to solve this equation for y, the first step that I need to do is to leave the log on the one side of the equation. So what I have is x minus x plus 1, so I push the -1 to the left side of the equation. So it becomes x plus 1 equals to log with base 2 of y plus 8. Now, my function is a logarithmic, the equation is a logarithmic equation. On the one side, I have a logarithm. This means that I want to introduce a logarithm on the left side of the equation as well. How do I do that? Well, the first thing that I want to consider is what is the base that I want to have for my logarithm. And the base is going to be determined by this base right here. So since I have the base 2 right there, I want to have a base 2 on the left side of the equation. Log with base 2 of log with base 2 of 2 to the x plus 1 is equal to the log with base 2 of y plus 8. Remember, I can always do this because I know that the log with base a of a to the k for any a k and k is equal to k. So this is what I apply in order to continue with my solution. Now I have two logarithms left and right that they are equal. They have the same base. Since they have the same base, I can drop them because the arguments of the logarithm will be equal as well. So I have 2 to the x plus 1 equals to y plus 8. I remind you that you want to solve for y. And in order to do that, you have to isolate it. So now y is going to be equal to 2 to the x plus 1 minus 8. And what is the y? The y is nothing else than f to the -1 of x, the inverse of my function. So the inverse of the logarithmic function log of y plus 8 with base 2 -1 minus 1 is equal to 2 to the x plus 1 minus 8. Assume that I want to graph now this function on my graph. Well, the truth is that I need 2 points. Always you need at least 2 points, probably more. It is a curve, so as a curve it would be better if we have more than 2 points. But the truth is that I know the curve of this function, the form of this function. It's a logarithmic function and it doesn't have any negative sign, neither in front of the 2 of the base, neither in front of the exponent. So this means that it will look like this. That's the first thing that I know. I also know 2 points. How do I know those 2 points? Well, I want to remind you that functions that they are opposite of each other, they have points that they interchange their coordinates. So if 0, 2 is a point of the logarithmic function, then 2, 0 right here is going to be a point that belongs to the exponential function. Also, since negative 7, 0 is a point of the logarithmic function, then 1, 2, 3, 4, 5, 6, 7, negative 7 right here, that is the 0, negative 7, is going to be a point that belongs to the exponential function. Now, since this is the vertical asymptote for my logarithmic function, then this means that the horizontal asymptote for my exponential function, the inverse of the logarithm, is going to also be equals to y equals to negative 8. Okay, so this means that my function will look like this. And it will be asymptotic on the X-intercept, on the X-asymptote, right here, the horizontal asymptote, y equals to negative 8. Another way to verify that what I did is correct is now go back and consider the line y equals to x, the line y equals to x. Now I want to remind you that all inverse functions, they are symmetrical around the line y equals to x. So, as you can see, the green line that expresses my exponential function 2 to the x plus 1, 2 to the x plus 1 minus 8, is symmetrical to the blue line, that is the log with base 2 of x plus 8 minus 1, and those two functions are inverse of each other.